In this video, we'll look at Le Chatelier's principle. When a system at equilibrium is subjected to a change, the system will respond to minimize the effect of the change. So we'll look at changes in concentration, pressure, temperature, and the addition of a catalyst. First, we look at a change in concentration. In this reaction, we have iodine reacting with chlorine to form iodine trichloride. So first we look at the case of adding iodine to the reaction mixture. If iodine is added to the reaction mixture at equilibrium, the system will respond by using up that extra iodine to produce more iodine trichloride. So by adding more iodine, the system will try to reduce the extra iodine you've added, and one way it can do that is by making more iodine trichloride. So we say that the equilibrium will shift to the right. Next, we look at the case where chlorine is removed from the reaction mixture. If chlorine is removed from the reaction mixture at equilibrium, the system will respond by producing more chlorine. So by removing chlorine from the reaction mixture, the system will respond to try to produce more chlorine. So the equilibrium will shift to the left. And the final point, a change in concentration does not change the value of Kc, which is the equilibrium constant. Next, we look at a change in pressure. In this reaction, nitrogen is reacting with hydrogen to form ammonia. This is also known as the Haber process. Changes in pressure will affect the position of equilibrium only if there is a change in the number of gas molecules. So in this reaction, we have 4 gas molecules on the left side and 2 gas molecules on the right side. So overall, there's a change in the number of gas molecules. If pressure is increased, the system will respond to decrease the pressure, and the equilibrium will shift to the side with the lower number of gas molecules. So in this reaction here, if we increase the pressure, the equilibrium will shift to the right, because this side has the lowest number of gas molecules. And by doing this, it can reduce the pressure in the system. The next point, if pressure is decreased, the system will respond to increase the pressure, and the equilibrium will shift to the side with a higher number of gas molecules. So if we look at this reaction again, if the pressure is decreased, the equilibrium will shift to the side with a higher number of gas molecules, which is the left side. So the equilibrium will shift to the left, and by doing this, it can increase the pressure in the system. And the final point, a change in pressure does not change the value of Kc. Next, we look at a change in temperature. The equilibrium constant Kc is temperature dependent, therefore changing the temperature will change the value of Kc. In this reaction here, we have sulfur dioxide reacting with oxygen gas to form sulfur trioxide. The delta H for this reaction is negative 198 kilojoules per mole. Because the enthalpy change is negative, that means the forward reaction is an exothermic reaction. So if the temperature is decreased, the system will respond by increasing the temperature, and the equilibrium will shift to the right. And that's because the forward reaction is exothermic, it releases heat. If the temperature is increased, the system will respond by decreasing the temperature, and the equilibrium will shift to the left. That's because the reverse reaction is endothermic, which absorbs heat. Here we have another example. This is methane reacting with water as a gas to form carbon monoxide and hydrogen gas. And the delta H for this reaction is positive 206 kilojoules. Because the enthalpy change is positive, that means the forward reaction is an endothermic reaction. If the temperature is decreased, the system will respond by increasing the temperature, and the equilibrium will shift to the left. That's because the backward reaction is exothermic, it releases heat. If the temperature is increased, the system will respond by decreasing the temperature, and the equilibrium will shift to the right. That's because the forward reaction is endothermic, it absorbs heat. And finally, we look at the change in Kc. A change in temperature is the only factor that changes the value of Kc. If the equilibrium shifts to the left towards the reactants, the value of Kc will decrease. That's because we have a higher concentration of reactants. If the equilibrium shifts to the right towards the products, the value of Kc will increase. That's because we have a higher concentration of products. So for example, in an exothermic reaction, an increasing temperature shifts the equilibrium to the left and the value of K decreases because we have a higher concentration of reactants. In an endothermic reaction, an increase in temperature shifts the equilibrium to the right and the value of Kc increases because we have a higher concentration of products.